Hello, I welcome you all. The problem reads when a force of 2 pounds is applied to the handles of the brad squeezer, it pulls in the smooth rod AB. Determine the force P exerted on each of the smooth brads at C and D. Right. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So what the problem is telling us that we have this machine, okay, and this machine is a squeezer, okay. It's able to hold, like in this case it's holding this material here. You've seen this material at C, this material, okay, and it's been held as this member here, okay, is being pulled, okay. As it is being pulled and then it rotates in an anti-clockwise direction, it exerts a force on member AB. All right. So as the member AB is tensioned, it pulls on this rigid bar CBD. All right. And later on, it squeezes this material here. And we have been asked to determine the force P. For me, I'm thinking maybe because the force is coming from the 2 pounds which is being applied to the handles by this particular hand. So I was thinking maybe P should not have been indicated because it shows as if this P is an externally applied force. So for me, I feel the diagram the way it was written, maybe P must not have been indicated, but the question should have read more or less the same, but just removing P. So determine the force exerted on the smooth brads at C, because there's going to be a force from this particular hand that is applying this 2 pounds. Okay. Yeah. So what I've done is I have removed the P. Okay. Just the labeling, but the question will remove the same. I've just removed the P and resolve it, okay, again, okay, and solve it again. So the way I've changed the question, I'm thinking maybe it should have been like this, okay. So everything remains the same. We are going to determine the force exerted on the brad C and D because the force is coming from this hand, so it means we know there's going to be a force in this particular frame machine. All right, so this is what I've done. Let's solve the problem quickly. I solved this, so I was just trying to resolve it by writing the diagram. Right. So what we're going to do is we're going to dismantle this, dismantle members of interest that we think are going to give us the solution, so that we find the force on C and D. So the assumptions, pin at A, B, and E. Okay, and then we are assuming a rigid bar. This is a rigid bar. The rigid bar is member C, B, D. Okay, all right, and then we are assuming this bar is right like so. This bar is something like this, where this part here is attached like this. Okay, this is our assumption. Okay, this is C, B, D. Okay. All right, so these are my assumptions that I'm going to work with, okay, in the problem. All right. So if that is the case, then we have a two force member. A two force member is AB. So I'll draw a free body diagram for this member here, this one here. Quickly, I'll draw this one here. I'll remove this one. Okay, so I'll draw this quickly. So it's something like this. Let me draw it. Right, I don't know. Maybe. All right. So let's say I have a pin there. This pin is a pin what? Pin E. And then let's say I have another pin here. This pin is pin A. And then let's say I have a force here. This force is 2 pounds. All right. And then since we have a pin at A and B, therefore member AB, and we've been told that the road, this road AB, okay, is as it moves in this assembly, this assembly, okay, there's no friction, it's smooth, there's no friction, okay, between the surface of this bar and the inner surface of this assembly. Okay, it is smooth, so there's no friction, it's just moving in there smoothly, so no friction. So, and then this AB is a two-force member, therefore there's only one single force in this particular bar. So if it's a two-force member, it is just going to be like this. Okay, so we have there is some tension force like so, and we are going to call this point here is A, this point here is B, right? This is force AB, let me call it that way. And then here I expect two forces. I have EY, and then there I have EX. Okay, these are the joints. And then also here I expect AB. So if we have this force here, then I expect here to have a similar force like this, AB. And then because as we pull this, there is a tension force that pulls on this bar. So this bar, these brads, you've seen these brads here. If I was to draw these, let me bring this here. I bring it here down here like this. I bring it here. Then I move this maybe on top. I move it on top like so. Okay. So let me bring this. So I'm just drawing visual free body diagrams here. All right, so this material here, we have a brad there like this, okay, which is being held. So we expect a force on this material like this, right? And let's call this force just P. We are just naming it P for now, okay? So this is a force on these brads or whatever material, they can be wood or whatever. So if you have this tendency here, then we expect a force there, P, like this. All right, is that fine? So we have all this. So let me just put show the distances. So this is 0.25 inches. This one is 2 inches. All right, this one is EY. Okay, what else? I think this is about it. And then here, this distances here is 1.5 inch. This is 1.5 inch, and this is 1.5 inch. Okay, so this is how I would disassemble this particular structure. So what we need to do right now is so here it is C, then there it is D. Okay, I can move that. So what we need to do is we're going to take moments, since we're interested in the force AB, we'll take moments at pin A. This is A, this is A here, and then this is E. Okay. We'll take moments quickly at pin E, summation of moments about pin E, so that we find a force AB, which later on will translate it to the rod, then the rod to this rigid bar. Okay, rigid bar CBD. Okay, CBD. All right. So this is AB. All right. So let's take moments quickly. So summation of moments about E equal to 0. Okay, what do we have? Okay, this distance here, we didn't show it. From E, from here, from E to A, this one here, this one is 1 inch. All right, so summation of moments about E. So what do we have? We have AB. AB, this is clockwise, right? It's clockwise. AB times the lever arm 1, and then plus 2 pounds times 2 pounds times the lever arm, which is 2, equal to 0. Therefore, AB is equal to 4 pounds. Okay, so we found what AB is. AB is equal to 4 pounds. Okay, which is the same as the other one there. So AB is equal to 4 pounds. So if we found AB, so is this AB here equal to 4 pounds. Okay, so if we have AB equal to 4 pounds, it means we can apply the equations of equilibrium here, okay, on this rigid bar CBD, so that we find what P is. All right, so let's do so. So summation of forces in the x direction equal to 0, in this direction like so, or reference positive. So that we have the 2p's, so we'll say minus 2p plus AB equal to 0. We know that our AB, we know already what AB is. We already calculated it. It is here. It is 4. So we just replace it there. Okay, if we do so, then we realize that our P is equal to 2 pounds. Okay, so I guess we are done. P is equal to 2 pounds. I hope we are done, and I hope the explanation was clear. If it was, please like my video, share my video, continue subscribing. Bye bye. See you in my next screencast.